For decades, we've been taught to think about data security like we're building a fortress. The bigger the walls, the safer we are. But what if that whole idea is wrong? What if the best defense isn't a stronger wall, but no wall at all? What if the very treasure we're trying to protect was constantly moving? Today, let's explore a radical new idea, using chaos itself to create the ultimate defense. So, first things first, why does any of this even matter? Well, it matters because of this number right here. $4.88 million. That's the staggering average cost of a single data breach in 2024. Clearly, the old ways of doing things just aren't cutting it anymore, and the price of failure is just astronomical. We desperately need a fundamental change in how we approach security. The traditional model is all about securing data at rest. We lock it down, we stick it in a fixed location, and we try to build these massive digital walls around it. The problem is, attackers have gotten incredibly good at finding the cracks in those walls. This whole static approach basically turns our most valuable information into a sitting duck. And when you really start to break down our current defenses, you can see those cracks everywhere. Firewalls? They're great, but they're pretty much useless against a threat that's already inside your network. Encryption? Absolutely essential, but it can really slow things down. And trust me, managing the keys is a huge headache. And access control? Well, those permissions get outdated so fast, and before you know it, you've got security holes all over the place. Every solution we have has a critical flaw. So that brings us to the big, game-changing question. What if we just stopped playing their game? Instead of trying to build the perfect, impenetrable vaults, what if we made the data itself impossible to even target in the first place? And this really gets to the heart of the whole paradigm shift. On the one hand, you've got the old way. Data at rest. It's static, it's predictable, and it's basically a single, juicy target for an attacker. But on the other hand, you have this new idea, data in motion. Now it's dynamic, it's unpredictable, it has no fixed location, it's just inherently elusive. You simply can't steal what you can't find. The science that makes this all possible comes from a really fascinating field, chaos theory. I'm sure you've heard of the butterfly effect. The idea that a butterfly flaps its wings in Brazil and could set off a tornado in Texas. Well, that's the core concept. Tiny, tiny changes leading to massive, wildly unpredictable results. And it's that very unpredictability that we can harness for security. So let's meet the technology inspired by this theory. It's called the Database in Motion Chaos Encryption Algorithm, or much easier to say, DaChE. And it's a completely new way of thinking about protecting our information, one that actually leverages chaos as its main shield. So, how does this actually work in the real world? It sounds pretty complex, right? Well, the creators came up with a fantastic analogy to explain it, and they call it the billiards stadium. Let's see how this picture really builds it out for us. Okay. Here are the players in our little game. First, the billiards stadium itself. That's your entire database environment. The balls that are flying around inside, that's your actual data, but it's been broken up into tiny encrypted pieces, or shards. And all those obstacles scattered randomly across the table, those are the decryption keys. Now here's how it all comes together. First, your database gets sharded. It's broken into all these tiny little pieces. Next, each piece is encrypted and put inside one of those balls. Then all these balls are set into constant, chaotic motion inside the stadium. So when you need to access some data, the system doesn't go looking for it, it just waits. A ball eventually collides with an obstacle that holds its matching key. At that exact moment of collision, the data is decrypted, your query is processed, and the answer is sent back to you. The whole thing happens in a fraction of a second, but only at that precise, random moment of collision. And here is the absolute crucial point. This is the magic of the whole system. Because all that motion is completely chaotic, no one, not an attacker, not an insider, not even the person who owns the system, knows the exact location of any single piece of data at any given time. The data has no permanent address. It is fundamentally untargetable. Okay, I know this all sounds incredibly secure, but is it practical? Can you actually use this stuff? Let's take a look at the real-world advantages of this chaotic defense, because this is where it moves from a cool theory to a true game-changer. So what makes this so much more than just a theory, are the practical benefits? It offers full SQL support, which is huge. It means it integrates seamlessly with the applications businesses are already using. It's also incredibly fast. It uses parallel processing to minimize any performance hit. Looking ahead, it's even designed to be post-quantum ready, which means it's built to resist the insane code-breaking power of future quantum computers. The security is also tunable. You can literally increase the level of chaos for more sensitive data. And finally, this isn't just a clever idea. It's backed by rigorous mathematical proofs and has achieved top security certifications. The creator of DaChE, Itzhak, he puts it perfectly. He says it, quote, represents a paradigm shift, harnessing the power of chaos theory. It's not just an improvement on an old idea. It really is a completely new way of thinking about the entire problem of data protection. So, to sum it all up, this is the strategic leap we're talking about. For years and years, we've been focused on building stronger, taller, thicker walls around our data. This new approach simply makes the treasure impossible to find. It's a much more elegant and ultimately a much more secure solution. Which leaves us with a final thought to chew on. In a world of increasingly sophisticated and unpredictable threats, maybe the best defense isn't more order and more control. Perhaps the future of security is embracing chaos itself.